In this video, we're going to start taking a look at streams, which were introduced in Java 8. Now, when you think of a stream, you might be thinking of I/O streams like input stream and output stream, but those aren't the type of streams that we're going to be covering here. So streams in this context are completely unrelated to input-output. So in this video, when we refer to a stream, we mean a sequence of computations. So another way of putting it is a set of computational steps that are chained together. Now we saw chaining in the last few videos, and we can chain predicates, functions, and consumers. We do something similar when working with streams. So let's start out by creating a new console project called Streams. And inside the main method, we're going to start by creating a list of strings that we're going to be needing here. I'm just going to make a bit more space. So I'm going to create a list of strings. List string. We're going to call this one some bingo numbers. Bingo numbers. We're going to set that equal to arrays.asList, so we're converting it to an array, or more specifically to a list of string objects. And we're going to be putting in some numbers here, so N40, N36, then B12, B6. Oops, B6 that should have been. And we're going to do a G53, G49, G60, G50, I26, I17, I29, then the last one O, as in the letter O, 71. Alright, so there's our list. And I just used the arrays.asList method to create and populate the list as you saw. Now looking at this list, let's say that we'd like to print out the bingo numbers that are in column G. Now we could use a for loop to iterate through the list and print those strings that begin with G, but now that we know that we can use the for each method in a consumer, let's have a go at doing that. So to print the numbers in the G row, like the row on line 12, we could start with something like some bingo numbers dot for each. Then we could start with the parameter number, arrow token, code block, and we could do something like if number dot starts with G, and we just print out the number like so. All right, and I'll just check my code level to make sure that's set to 8. Project, the lambdas, that should fix that up. Okay, now that's obviously all pretty straightforward. We're using the starts with method to find all strings in the list that begin with G. And if we run this, we should see that the 4 numbers that are in column G, or the columns that have got G in them, should actually appear. So let's just try running that. And you can see we've got our 4 G numbers, so that's working well. Let's move this down to the bottom. All right, so let's now add another number, but we're going to add it to the same column, but we're going to use a lowercase g just to see what happens. So I'm going to do G64. And if we run this, so we find that we still got the same results as we got last time. So in other words, the G64 with a lowercase g wasn't picked up. And that's of course because our test at the moment is using starts with a capital G. So we can then change this and put number 2 uppercase dot starts with G. And that should allow us to see the 5th number that we added. G64 is now showing as well. But let's now sort the strings before we print them, because we'd expect G49 to be printed before G53. So we're going to add each item that passes the starts with condition into a new list, and once we've checked all the strings, we can then sort the new list. But wait, we've got an issue here. We're using for each, which operates on one element at a time. Can we declare the list before the for each call and use it with the for each lambda expression argument? So let's try it, and we'll keep the print statement in there for now while we're doing this. So we could do something like outside of the for each statement, we could do a list string, we'll call it G numbers, equals new array list. So just create an empty one for now. Then within the actual loop, we do something like G numbers dot add number. Now IntelliJ is not complaining here, but remember the scoping rules when using lambdas. Now the scope of this lambda is within the scope of the main method body. So we can use variables declared in main in lambda expressions inside main as long as those variables are effectively final. In this case, we're changing the contents of our G numbers list, but the object reference stored in the G numbers variable doesn't change. And so G numbers is effectively final, and therefore we can use it within the lambda. So now that we know it will work, let's actually remove the print from the lambda and add the code that's going to do the sorting and printing. So I'm just going to remove the print out there. And then outside of the for each, because we've got our list of numbers that we want to sort now in the G numbers variable, the array list that we created on line 17. So we can do something like G numbers dot sort. We can do string S1, string S2, arrow token S1 dot compare to, and too many brackets there, compare to S2. Then we can do G numbers dot for each, string S1, or string S6 actually, because we only need the one here. Let's just print it out, and we'll print it out. Arrow token, and we can just do a system out for S. Right, so let's first just try running that to see that it works and it sorts things correctly. And you can see things are now sorted in the right order. Now we could have used an anonymous class here for the comparator and a for loop instead of a for each. But this is a lambda expression section, and that's why we're using lambdas here. Now we're using two for each calls rather than looping. We're using a lambda for a comparator, and we don't need to specify the parameters, the parameter types in any of the lambdas, but I sometimes like to see them there for readability. So I've kept them there for the sort and print lambdas, since without them we wouldn't be able to tell at a glance that we're working with strings, as we can when we're uppercasing and calling starts with. Apart from that though, perhaps there's a more concise way to accomplish what we want to do, even though this is already pretty concise code. So to create a new list, gather all the G numbers and sort them and print them, we're using for statements. So we're obviously creating the G numbers list initially on line 17. Now we're then adding all numbers beginning with G to the list, and we're doing that on line 21. We're sorting the list on line 26, and on line 27 we're printing the list. Now what if I told you that you could actually do everything there in one statement? Well, this is where streams come in. So I'm going to update the code to use a stream, and then we're going to actually discuss it. Well, in fact, what I'll do here is I will actually just comment out this code here so you've got a reference to the old material. Then let's just do the equivalent code with a stream. We can literally replace that with one line, as I've mentioned, and that can be some bingo numbers. Then we do dot stream dot map, and it'll be string colon colon to uppercase dot filter, and it's going to be S arrow token S dot starts with G dot sorted, and then last line dot for each, and it's going to be system dot out colon colon println, and that's actually it. All right, so let's just run this. Just confirm that it works. We can see that it has worked there. It's still sorted, but did you note that the number for G64 is now printing with an uppercase G? We'll see why that happened when we step through each part of this statement shortly. But the first method we call is stream, so it's time now to define officially what a stream is. Now, if we take a look at the documentation, you can see that Oracle defines it as a sequence of elements supporting sequential and parallel aggregate operations. So what does that actually mean? Well, in practice, a stream is a set of object references. The stream method, which was added to the collections class in Java 8, creates a stream from a collection. Now each object reference in the stream corresponds to an object in the collection, and the ordering of the object reference matches the ordering of the collection. Now when we want to use a stream that uses a collection as a source, or as its source, the stream method will always be the first call we make. So going back to our source code. So note that the source collection, which in this case is the sum bingo numbers list, won't be changed when we work with streams. In fact, any stream operations that we use have to meet two requirements. Firstly, they must be non-interfering, which means that they don't change the stream source in any way. And secondly, they must be stateless. So the result of an operation can't depend on any state outside of the operation. An example of that would be that it can't depend on variable values in a previous step. So each operation should be seen as an independent step that's operating on a stream argument. So the result here of the stream call is a stream that contains all the items in the sum bingo numbers list in the same order that they occur in the list. So next, coming down to line 30, we call the map method, and we're passing it a method, the string.toUppercase method, but note that we've written it as string : toUppercase with no parentheses. Now, you may not have actually seen methods referred to using the : notation. Now, this notation is called a method reference. So we can use them when all a lambda does is call an existing method. Now, we could have been using them all along, but I figured it was a good place to introduce them here rather than earlier on. So the map method accepts a function. And from previous videos in this section, we know that a function accepts one argument and returns a value. In this case, we're mapping the string.toUppercase method to function. So the method itself doesn't accept a parameter, but there is a source string. And it's the string object we're using to invoke the method. So that's mapped to the argument of function, and the return value is the string returned from toUppercase. So another way to look at this, if you're a little bit confused by that, would be this code here. I'm just going to paste some code on the screen. So looking at this statement here, that effectively would map to something like this. So string upper string equals toUppercase my string. So it's just really another way of sort of showing it on the screen there. And because the string.toUppercase method can be mapped to function in this way, we can then pass it to the map method as a method reference. Now there's nothing stopping us there. I'll just delete this extra code here now. We could have actually come back here to the map, and we could have actually written it the old way. So we could have done something like s for the parameter, arrow token s.toUppercase, and that would be valid as well. But here we're now looking at this new format with a double colon, so I put that back in as it was before. So to use a method reference for a method that takes parameters, the compiler has to be able to infer what the arguments are. Now we can't use a method reference for the starts with method on line 31 because there's no way for the compiler to know that the argument should be G. And for more information about method references before we finish the video, check out this link. Useful for you to spend a bit of time looking at that and just going through that information there. Alright, so let's continue on this in the next video.